Let's understand the meaning of consistent pair of linear equation. So we'll take example linear equation 2x plus y minus 6 is equal to 0. Now to plot this linear equation on a graph, we need two values of x and y. So we need two solutions of this equation. The simple way to find out the value of variables is to assume the other variables value 0. That means if we assume x value 0, then we'll get y, and if we assume y's value as 0, then we'll get x. So let's assume that x is 0. So if x is 0, then the equation will become 2 into x, that means 2 into 0 plus y minus 6 is equal to 0. Now solving this equation further, we'll get y is equal to 6, because 2 into 0 is 0, then adding plus 6 to both sides we get y is equal to 6. When the value of x is 0, y has value 6, so we can write this solution as 0, 6. Now let's assume value of y as 0. In the first case we assume value of x is 0. In the second case we are assuming value of y as 0. Now putting the value of y equal to 0 in the equation, what we get? 2x will remain as it is, y is 0, minus 6 is equal to 0. That means 2x is equal to 6. Dividing both sides by 2, we get x as 3. So when the value of y is 0, x has value 3. So this is our second solution to the equation. X has value 3 and y has value 0. Now let's plot these points on a graph. So this is the graph. Now the first point is 0, 6. Let's call this point as P1, and the second point is Q1. Now the point P1 has coordinates 0 and 6. That means it has x coordinate as 0 and y coordinate as 6. Therefore the point will lie on y axis. So the coordinates are 0, 6. Then Q1 has coordinates 3 and 0. So its y coordinate is 0. That means it will lie on x axis. The point is here. Now let's draw a line passing through P1 and Q1. So this is the line passing through point P1 and Q1. Now this line represents the linear equation 2x plus y minus 6 is equal to 0. Now let's take another linear equation. The linear equation is x plus 4y plus 4 is equal to 0. Similar to first linear equation, let's assume the value of x as 0. Now if x has value 0, that means linear equation will become x is 0 plus 4y plus 4 is equal to 0. That means subtracting 4 from both sides, we get 4y is equal to minus 4. Dividing both sides by 4, we get y is equal to minus 1. So we got the first solution to the linear equation x plus 4y plus 4 is equal to 0, where if the value of x is 0, y has value minus 1. So let's mark it as 0, minus 1. Now let's assume the value of y as 0. So what we get? The equation will become x plus 4 into y. That means 4 into 0, because y has value 0 plus 4 is equal to 0. That means x plus 4 is equal to 0. So x has value minus 4. If we subtract 4 from both sides, we get x is equal to minus 4. So at value of y is equal to 0, x has value minus 4. So we got our next solution to this linear equation, where x has value minus 4 and y has value 0. Now let's plot these points on the graph as well. So this point is, we call it as P2, and this point we call it as Q2. So the point P2 will lie on y-axis because its x coordinate is 0. So 0 minus 1 will lie at this point. So let's mark it as P2. Then the point Q2 has coordinates -4 and 0. So its y coordinate is 0, hence it will lie on negative x-axis. So let's name it as Q2. Now let's draw a line passing through P2 and Q2. So this line represents the linear equation x plus 4y plus 4 is equal to 0. These two lines are intersecting each other at one common point, and this point lies on both the lines. That means this point satisfies both the equation 2x plus y minus 6 is equal to 0 and x plus 4y plus 4 is equal to 0. So the common solution to this equation is the point on the graph where the two lines intersect. Now what are the coordinates of this point? It has x coordinate as 4 and y coordinate as -2. So its x coordinate is 4 and y coordinate is -2. Now let's check whether this point satisfies both the equations. So the solution to this linear equation is 4 minus 2. Now let's verify whether this solution satisfies the given linear equation. So the first linear equation is 2x plus y minus 6 is equal to 0. So the left hand side of this equation is 2x plus y minus 6. Now let's put the value of x and y in this equation. So x has value 4 and y has value -2. So 2 into x is 4, y has value -2, -6. Now 4 2s are 8, 8 minus 2 minus 6. Now this value is 0, which is equal to the right hand side of the equation. So we have verified that this common solution satisfies the linear equation 2x plus y minus 6 is equal to 0. Now let's check the solution 4 minus 2 against the second linear equation as well. So we are going to check the values 4 minus 2 against the linear equation x plus 4y plus 4 is equal to 0. Here x will have value 4 and y will have value -2. So the left hand side of this equation is x plus 4y plus 4. Now putting value of x, which is 4, plus 4 into y, y has value -2 plus 4. That means we got 4 plus 4 is 8, minus 4 into -2 is -8. So at the end we got 0, which is nothing but the right hand side. So we have verified that the common solution 4 minus 2 satisfies both the linear equation. Hence this pair of linear equations is consistent. So this pair of linear equation is consistent as it has a common unique solution. There will not be any other solution to this linear equation apart from this intersecting point. So we call these two linear equations as consistent linear equations. Let's discuss about dependent pair of linear equations. So we'll take the same linear equation 2x plus y minus 6 is equal to 0. Now from earlier case we found that it has solution. So it has solution, let's call P1 as if x has value 0, then y has value 6, and if y has value 0, so if y has value 0, then x has value 3. So the linear equation 2x plus y minus 6 has these two solutions 0, 6 and 3, 0. Now let's plot this solution on the graph. So the point P1 will lie on y-axis as its x coordinate is 0. Then point Q1 will lie on x-axis as its y coordinate is 0. So the point is 3, 0. Now let's draw a line passing through P1 and Q1. So this is the line passing through point P1 and Q1. This line is nothing but representation of linear equation 2x plus y minus 6 is equal to 0. Now let's take another linear equation. The linear equation is 4x plus 2y minus 12 is equal to 0. Now let's assume the value of x as 0. So what we'll get? 4 into 0 plus 2y minus 12 is 0. That means 2y minus 12 is equal to 0. So adding 12 to both sides we get 2y is equal to 12. So y will have value 6. Now this gives first solution to the equation 4x plus 2y minus 12 where x has value 0 and y has value 6. Now let's assume value of x other than 0. So if x is 1, then what will happen? The linear equation will become 4 into 1 plus 2y minus 12 is equal to 0. That means 4 into 1 is 4. 4 minus 12 is minus 8. So 2y minus 8 is 0. That means 2y is equal to 8. So dividing both sides by 2 we get y is equal to 4. So we got second solution to the second linear equation as if x has value 1, y has value 4. Now let's draw these points on the graph. So we call it as P2 and this point will be Q2. So the first point 0, 6 is nothing but the same point as P1. So let's mark it as P2 as well. So this is the same point. Then the next point is 1, 4. So Q2 is 1, 4. That means on x-axis 1 and on y-axis it is 4. So the point will be here. Now let's draw a line which will pass through P2 and Q2. If you see that both the lines are overlapping each other, so these two linear equations will have infinite solution. So we can see that these two lines are coincident to each other. That means every point that lies on one line lies on other line too. So these two lines have infinitely many solutions. As both lines are coincident to each other. So this is a case of dependent pair of linear equation. So the linear equations having infinitely many solutions are called as dependent linear equations. Now why these two linear equations have infinite solution? If you see the second equation 4x plus 2y minus 12 is equal to 0, and if you divide both sides by 2, what we get? 4x will be divided by 2, so 4x will be divided by 2 plus 2y will be divided by 2 minus 12 will be divided by 2 is equal to 0. Now after division what we get? 4x by 2 is 2x, 2y by 2 is y, minus 12 by 2 is 6 is equal to 0. So the equation 2x plus y minus 6 equal to 0 is nothing but the same equation 2x plus y minus 6 is equal to 0. So the two lines are one and the same lines. Let's discuss the case of inconsistent pair of linear equation. So the first linear equation is 2x plus y minus 6 is equal to 0, for which we already know the solutions of this equation. So the point P1 has coordinates 0, 6. That means if x has value 0, then y will have value 6, and q1 has values 3, 0. That means if x coordinate is 3, then y coordinate is 0. Now let's plot these points on a graph and draw a line P1, Q1. The point P1 will lie on y-axis as its x coordinate is 0. So the point is 0, 6. Then the point Q1 will lie on x-axis as its y coordinate is 0 at position 3, 0. Now let's draw a line passing through P1 and Q1. So this is the line P1, Q1. This line represents the linear equation 2x plus y minus 6 is equal to 0. Now let's take another linear equation 4x plus 2y minus 6 is equal to 0. Now let's assume the value of x as 0. So putting this value in linear equation 4x plus 2y minus 6 equal to 0, what we get? 4 into x is 0 plus 2y minus 6 is equal to 0. That means 4 into 0 is 0, then 2y, and adding 6 to both sides we get 2y is equal to 6. That means y will have value 3. Now this gives first solution to the linear equation 4x plus 2y minus 6 is equal to 0, where if value of x is 0, the value of y is 3. So we can write it as 0, 3. Let's call this as point P2. Now next assume the value of y as 0. Now putting the value of y in linear equation, we get 4x will remain as it is plus 2 into y. So y is 0 minus 6 is equal to 0. That means 4x is equal to 6. After adding 6 to both sides, we get 4x is equal to 6. That means x will be 6 by 4. And dividing numerator and denominator by 2, we get x is equal to 3 by 2. Now this gives second solution to the linear equation, where if x has value 3 by 2, then y has value 0. Let's call this point as Q2. Let's plot point P2 and Q2 on the graph. So P2 has coordinates 0, 3. So it will lie on y-axis as its x coordinate is 0. So this is our point P2. Then Q2 has coordinates 3 by 2 and 0. So its y coordinate is 0. That means it will lie on x-axis at 3 by 2. 3 by 2 is this position, the exact midpoint of 1 and 2. Now let's draw a line which will pass through P2 and Q2. So this line is P2, Q2. Now this line is nothing but representation of linear equation 4x plus 2y minus 6 is equal to 0. Now from the graph it is clear that these two lines P1 Q1 and P2 Q2 are parallels to each other. Hence these two lines will not intersect each other. That means these two lines will not have any common points. Hence the two linear equations will not have any solution. As the lines are parallel, there is no solution to this linear equation. So this is called as inconsistent pair of linear equations. The linear equations which don't have a common solution are called as inconsistent pair of linear equation, and these linear equations are represented by parallel lines on a graph. Now let's summarize the three conditions. In case of first pair of linear equations, the lines were intersecting each other and has exactly one solution. That means the intersecting point. For the second case, the lines are coincident and it has n number of solutions. And in the third case, the lines were parallel and there is no solutions, as these lines do not cross each other or do not intersect each other. Now this can be represented algebraically as well. In the fourth column, the ratio of a1 to a2 is taken. So what is mean by a1? A1 is nothing but the coefficient of x in the first linear equation, and a2 is the coefficient of x in the second linear equation. Similarly, b1 is the coefficient of y in the first linear equation and b2 is the coefficient of y in the second linear equation. Now c1 is the constant in the first linear equation and c2 is the constant in second linear equation. And if we take ratio of all these coefficients respectively, we get algebraic condition of consistent, dependent and inconsistent equation. So if the ratio of a1 to a2 is not equal to b1 to b2, then the linear equation is consistent. If all the three ratio, that means the ratio of coefficient of x, y and the constant term are same or equal, the equations are dependent as well as consistent, as there are n number of solutions. Now in case of parallel lines, the ratio of coefficient of x and y, that means a1 by a2 is equal to the ratio of coefficient of y, that means b1 upon b2, but it is not equal to the ratio of constant terms. In this case, the linear equations are inconsistent. Now that means by looking at the coefficient and the constant terms and by taking ratios, one can easily determine if the pair of linear equation has consistent solution or dependent solution or inconsistent solution.